All right. Now, if you ended at 11 and you brought out an x squared like you should have, you would have been left with 2x minus 6y. Then you always have to check. 2 and 6 share a factor, yes? So you would bring that 2 out. And just like in everything else we've done, simplifying radicals, lowest common multiple, everything, that 2 becomes a coefficient. 2 times 11 gets me 22. Okay? You always have to check. All right. Whoa, geez, that jumped far. 8C, no D because this guy doesn't have 1 to give. 3C squared minus 2D squared plus 7CD4. 5, 1 minus 2Z minus 3Z squared. 3, G plus 2. And 4D, 2D plus 3, D, not 2D, 2 plus 3D squared. 3D. Okay? No questions, right? We're just dividing. Everyone's cool, yeah? What was that? Some kind of twitch thing? Fair enough. SA equals pi r squared plus pi rs. Factor that. Why is this here when we did surface area so long ago? Why is it here?
Because this math also applies to that.
Yeah, the skills of factoring are useful all over the place. Watch what happens when you factor this. What's the same in both? Pi and r. So what's the greatest common factor? Pi and r. What'd you do to your finger?
I got glass on.
Oh. And what's left? Plus. That is the exact same formula as that. Significantly easier, I think, to use. Because what happens down here? Radius is 5, slant is 2. Pi r 5 plus 2. 7 pi. Pi. 5 pi times 7, 35 pi. Everybody cool? This is where factoring is useful. Right? Remember how I said this whole unit is not something I can really show you a real life use for? Because there isn't really one. But if you're doing higher level math with a bunch of crazy stuff in it, you can get it significantly simpler by being able to factor. Everybody good? And then, just to make sure, I threw in 4 multiplying, which is, of course, the reverse of factoring, yes? Are you checking for a fever? Okay. X squared plus 2x minus 15. 6x squared minus 8xy. X squared plus 6x plus 8. And x squared minus 6x plus 8.
Wouldn't it be the 2x minus 4x?
2x squared minus 2 times 4, 8xy. Well, what?
Wouldn't it be like 3x squared minus 4xy?
2 times 3 is 6. X times x is x squared.
Oh, so we're not making it smaller?
No, that's why it says expand. Yeah, we already did all this last unit, remember? Yeah, okay. Okay. Why? Why you gotta do that? Please don't. It drives me crazy. It's the distributive property, Josephine. Okay. Well, you guys won't call it by its real name, so why should I call you by your real names? Pardon me? All right, are we all good with GCF? We're all good with expansion, yes? All right, turn the page over. So, notice this is number 2, okay? This is factoring a trinomial. Now we're going to write the trinomial out in general form. General form means there's no numbers, okay? It's just what a trinomial looks like. Everybody cool? The first kind of factoring, GCF, we've already talked about. Everybody says they're good. So now let's do this one. This one is for a piece of an expression of math that looks like this. Okay? A, B, C are numbers, X and X are a variable. Now, of course, the X can be any letter, right? And the A and the B and the C are more places. A is is the coefficient that is with the X squared. All right? This is called the quadratic term, which you don't need to know. I'm just saying it. So if I discuss quadratic, like where in the trinomial something is, you know what I'm speaking about, okay? This guy is called the linear term, and this one is called the constant. Okay? Now, when they're in proper order, it's quadratic, linear, constant. That's the order they should be in, and they can be plus or minus. Now, the trinomial factoring that we are going to do is for when A equals 1. So would it look like this? No, it would actually look like this. X squared plus bx plus c. All right? This is the factoring you're doing right now. Later, you will learn how to deal with this when it's not a 1. Okay? But right now, it's a 1. Is everybody good? All right. Now, if we are going to do this with a drawing, we need to break this trinomial down into the rectangle, yes? Now, have a good look at that. In the middle is where the product has to be, yes? And this is the product, right? The factors will live on the outside. So how can we break this up to fill up a rectangle? Now look closely at it. One of those 3 terms we have no choices with, do we? Which term is that? X squared. Because there's only one of them, right? So that guy's got to live there. No question about it. Which automatically means what are the first 2 terms of my factors? X and X. Because that's the only way I can make that X squared, right? Now I've got some choices, don't I? Somehow I need to fit 8 X's in there and 7 singletons, right? How am I going to do that? Well, let's think about this. Can I put a singleton there? No, why not? Because I need that stretch, don't I? Okay. Can I put a singleton there?
No.
Why not? Because I have this stretch here, don't I? All right, so I can't put any singletons there. And I've already got my x squareds. So what must go here? I got to put a singleton there, don't I? Right? Okay, so now we're in business. So now one of my factors has to have a singleton, right? Okay. And then what would happen? What would this be? That would be an x, right? All right, so now, knowing what you know, talk to your neighbor. Try and make a rectangle in there. See if you can fill this out. Some of you already know how to do it. That's fine. Some of you don't. So see if you can fill this out. You should have enough of a hint to figure this out now. I'll let you guys have another minute to talk amongst yourselves. Does everybody have an idea of a way to go about this? Everybody cool? All right. You already established that obviously I need x's here, yes? Right? And obviously I need x's here, right? It's the only way we can do it. Okay. So right now, what do I have there? 2 positive x's, right? Are there any positive x's in my answer? No, there isn't. So since this is positive, but both of these have to be negative, what do I got to put here? A negative. Everybody good? So what does that make these? Negatives. How many do I need? 8. How many do I have? 2. So I could either stretch 6 out here or 6 out here. Are they going to be horizontal or vertical? They're going to be vertical, right? 1, 2, 3, 4, 5, 6, 7, 8. All negative. Right? Which means what are all these? Negative. Right? What's a negative times a negative? Positive. 1, 2, 3, 4, 5, 6, 7. Everybody with me? Positive x squared? Got it. Negative 8x's? Got it. Positive 7, got it. Everybody good? So what are the factors now? X minus 7 and x minus 1. Everybody cool? Even if you don't really get the algebra tiles, everybody see the thought process behind it? Because you know as well as I do what I feel about these things. And you know I'm going to show you another way to do this in like 2 seconds, right? So you just need a tenuous grasp on this. Preston, you're good? You're not saying you're good because I just told you I'm about to show you another way to do it? You're really good? Okay. Everybody is at least tenuously holding on, yes? You're Tom Cruise at the beginning of Mission Impossible 2 where he's hanging off the cliff with one hand and the helicopter comes and saves him. If you haven't seen Mission Impossible 2, don't waste your time. It's the worst of the Mission Impossible movies. By a mile. It's so bad. But I was so excited for it because it was directed by legendary action director John Woo. It was going to be awesome. All my friends who were movie nerds were like, yeah, man, yeah. And then it was so bad. So bad. We hated it. Everything. All the stuff John Woo liked to do in his Chinese movies didn't work in his American movie. I don't know why. All right, let's carry on. Expand that. What do you get? X squared plus 6x plus 4x plus 24, right? Which got you what? X squared plus 10x plus 24, right? I'm going to highlight now 4 things on the screen. And I want you to figure out the pattern. Everybody ready? Suhani.
For the 7, or sorry, for the first one, the 8 squared, you're basically taking 7
Ganika.
So basically, negative 7 minus 1 is negative 8.
Mm-hmm.
And then 4 plus 6 is 10.
Excellent. Now I'm going to highlight 4 more things. And I'm going to ask you to figure out that pattern, but you already have while I'm erasing. Ganika.
So 7 times 1 is 7, 4 times 6 is 24.
Exactly. Everybody see it? So, what does that mean? If I have, wait, let me get my view back to 150. X squared plus bx plus c. If, please underline if, this trinomial is factorable. Now, since I put the word if there, what does that mean? It's not always going to be factorable. If this is factorable, it will break down into 2 binomials. Those 2 binomials are x and x, okay, plus, and I'm going to write 2 other letters, m and n. And how it works is m plus n has to equal b, and m times n has to equal c. And once you can find that combination, you can factor a trinomial. Is everybody cool? Now let's look at this without writing. Here's what I started with, right? So I know that in my final answer, m and n have to add to 10, and multiply to 24. So all you do is start looking at 24, the pairs of 24. 1 and 24 will not get me 10. 2 and 12 could get me 10, but only if one of them was negative. Can't have negatives because everything down here is positive, right? 3 and 8 won't get me to 10. It gets me to 11 or 5. 4 and 6, that will get me to 10. So that's my pair. And they both have to be positive because both of these are positive. Is everybody good? Okay. Let's make sure. What do I have to multiply to and add to in the first one? Multiply to what? Negative 18. Add to what? What do I got to add to? 7. Is it 1 and 18? Will 1 and 18 get me to 7 in any way when I add them? Is it 9 and 2? Yes. How? How will 9 and 2 get me to 7? 9 minus 2, right? So x plus 9, x minus 2. Then I check. X times x, x squared is good. Negative 9 minus 2 is negative 18. 9 minus 2 is 7, and I'm aces. Everybody good? That's how easy it is. Now, some of you will be taught a different way to factor these. I've been doing this for 23 years. I have seen hundreds of ways to factor these things. I am telling you right now, this is the most efficient method. You never have to guess. You never have to worry. Thank you. This works. I cannot stress it enough to use this. In this version of factoring, Most people don't use any other method. When we get to when we've got a number out here, then there's 3 or 4 methods. Again, I will show you the one that honest to goodness works best. I am not lying. I've experimented with it for 20 years. I know what one works best. If you can't figure it out, I'll try to show you other ways. I know the screen just went down because I was looking at Marianne and out of the corner of my eye I saw it go blue. I don't know why this continues to do this. Well, I do know why it continues to do this. All right? This is so easy. Once you practice it a little bit, you will start seeing the pairs before you even write it down. What's this one? Whoa. We're at B. Obviously, we started at A. So what's this one? X minus 2 and x plus 4 is what Thomas says. Is that right? No. Why is it wrong? Because negative 2 plus 4 is not negative 2. You got the signs switched. Okay? Which I'm glad that happened because it allows me to say normally order doesn't matter too much when we're multiplying, does it? But it matters here because we're also adding. Everybody good? So this guy is what? Is it 1 and 35? No. Is it 5 and 7? Yes. How do 5 and 7 get me to negative 12? Well, it must be negative 5 and negative 7. Right? Everybody got it? Yeah. Easy peasy lemon squeezy, yeah? Great. What's D?
4.
I got to multiply to negative 20 and add to positive 12. What is it? 10 and 2? And which one is negative?
2. Wait. Yeah.
Okay, so it's going to be A plus 10 and A minus 2?
No.
No, why not?
Because that would be
That won't get me 12, will it?
So they're both positive.
They're both positive? Okay, then 10 plus 2 is negative 20?
Oh, they're both negative.
Okay, they're both negative?
No.
So now negative 10 minus 2 is positive 12. Why did I ask you to underline that? So, what is the answer here? It does not factor. Don't force the math. Okay? That's the danger of learning patterns. Right? That's why I showed you the drawing. That's why I showed you the if thing. Right? I didn't jump right into this. I could have saved the first 15 minutes of this class by just showing you this pattern, right? Because 99 times out of 100 it works. But if I did that, then this question kind of messes kids up, yeah? All right, what about E? I got to add to negative 5 and multiply to negative 14. What is it? Y minus 7. Y plus 2. Yeah? Everybody good? What's different in F?
There's 3 numbers.
There's a 4 in front of it. We don't know what to do when there's a 4 in front of it. So what's the thing that we're always supposed to do if we can? We're always supposed to GCF, right? Is there a GCF there? What is it? 4. X squared minus 5x minus 14. Now, that is just that, isn't it?
Yeah.
Right?
Yeah.
So, would we stop factoring? No. We check this, and we know that it's x minus 7, x plus 2. Everybody with me? Now let me ask you this. Would this be all right? Is the red one still right? Why? because that doesn't matter. The brackets keep these together, right? All right, if it does it again, I'm going to take matters into my own hands. What am I doing with G?
The thing you give
Yeah, what's coming out? 10. And what's the answer? Some of you, like I said, are probably seeing this without even writing out anything now. But I'm going to continue to write at least the first bits. Add to 8, multiply to 12. What is it? Plus 6, x plus 2. What's happening in H? This is one of those weird ones I was talking about at the very end of last class. What don't we like there? Suhani? I don't like that -4. Now, normally we call it greatest common factoring, yes? But -4 is smaller than 4, isn't it? But we're still going to take out a -4 because we don't like a negative at the beginning of a bracket. Okay? So this is going to be -4. Now what's going here? T squared. What's going here?
4
Plus 4t. What's going here?
negative minus
32. Now, does that look factorable? Yeah, okay. Screw this piece of crap. Move your desk a little. Sorry, everyone. You know as well as I do, technology blows. Oh, really? So while you're waiting for me, you should be factoring t squared plus 4t minus 32. And then, while you're waiting on that, you should try I. Yes. Sean, pull your desk back a little so I can throw that down there. Sorry, everyone. It's the best I can do. Now you'll have to tell me if the screen has scrolled off of here. And you will see my fat hand in the way. But it's all we can do. Multiply to -32. Add to 4. What is it? X plus 8. Not x, t. Right? Okay, what's weird about I? The square's in the wrong spot, yeah? So, can we move it around? Can I write this? Okay. Do we like a -d at the front? So what should I do? Divide by? Not d. -1. Because I'm always allowed to divide by -1, right? And that gets me -d squared plus 5d plus 24. Now, can I factor that? It looks like I can because you think 8 and 3 are going to work, don't you? But why won't they? Harsh? Yeah, I can't make 8 and 3 get me to +5, can I? One would have to be negative. So this is the only factoring we can do here. Everybody with me? What's different about J? Oh, sorry, McKenna. Yeah. I shouldn't have written X. I said X, but it's supposed to be T. And then it's the exact same thing we're doing all the way along. We needed numbers that multiplied to negative 32. 8 times negative 4. And 8 minus 4 is 4. Okay? I know I wrote X, but... All right, what's different in J? There's what? There's an extra variable, right? We know that V and V will make V squared. So what obviously do I need at the other side to make B squared? B and B. What is happening here is this. It's the exact same thing as that, right? What would you do for that? Well, you would need to add to 19 and multiply to negative 20. What is it? 1 and 20, right? Which one has to be negative to get to 19? 1. So it's V minus 1, V plus 20. And then, because I have a B there, I got to have a B here. Everybody cool? Great. You guys do K. What is it? $14y and x minus 2y. Is everybody getting the drift here? Yeah? Brendan.
The only thing that I kind of don't understand is when you put positives and negatives.
Okay. Okay. So let's work on that in L. All right? What's got to come out of L? Just B, right? Because I know what to do if there's an A squared there, and I know what to do if there's a B squared there. So we're going to take a B out of there. And now I've got A squared minus AB minus 20B squared. Yes? And then I need to multiply to add to negative 1 and multiply to negative 20, right? Now, Brendan, I'm going to write more stuff here because it's going to address the question you just had, okay? Will 1 and 20 get me to 1? In adding in any way? No. 2 and 10? 4 and 5? Yes. How, Brendan, will 4 and 5 get me to negative 1? Pardon me? No. We're on the adding section now. How can I add 4 and 5 to get me negative 1? Is it 4 plus 5? Is it 4 minus 5? Is it 5 minus 4? It's 4 minus 5, right? That will get me negative 20. And if I add them, it'll get me negative 1. So that's how you know where to put the pluses and the minuses. So it's B, A, and it needs to be minus 5B, because I need a B squared, and plus 4B. Good? Okay. Another way that helps, if this guy is negative, then it's got to be plus and minus. If this guy is positive, then they got to be the same sign. If that guy's positive, they got to be both positive. Okay? So let's look at M. How does M differ? It's x to the 4th, yes? Now, x squared, a squared. And the final answer was xxaa, right? What are we doing to that first term? We're taking a square root, aren't we? So what am I doing here? Taking a square root. What's the square root of x to the fourth? X squared. So this is x squared and x squared, right? Because all I've done all the way along is take a square root. Now, I need to add to negative 15 and multiply to 50. Is it 1 and 50? 2 and 25? No. 5 and 10? Yes. How do 5 and 10 add to make negative 15? They're both negative. And then I just check. X squared, negative 10x, negative 5x, negative 15x squared, negative 5 times negative 10, positive 50. Everybody good? All right, now there is where this type of factoring officially ends. Because look at the next one, and you see it's written weirdly, yes? What is weird about the way I've written n? 0n, we would never write that, would we? It would just be blank, right? This should be x squared minus 9, right? But I've written it this way for a reason. When you see it as a trinomial, that means I can factor it by adding to 0 and multiplying to 9. Negative 9, I mean. Is it 1 and 9? Is it 3 and 3? Yes. How do 3 and 3 add to make 0? 3 minus 3, correct? So what would this be? X, because we take the square root, right? Minus 3 and x plus 3, right? What's going to happen in O? Same thing. Now look closely. There's a pattern here. What is it? You already know what we do with the first term. Square root. What are we doing with the second one? Square root. So what's this one? X plus 25 and x minus 25. Everybody see? Now, look at P. P looks similar, but it's slightly different. Can I square root that?
Yes.
Can I square root that?
Yeah.
But what's different in P?
8.
There's something in the middle, yes? So, it can't be plus and minus, because that's going to make that linear term drop out, isn't it? Mm-hmm. So what must it be?
Plus and 4.
Exactly. X plus 4. X plus 4. What if it was x squared minus 8x plus 16? Then what would it be? X minus 4. X minus 4. What would it be if it was x squared minus 0x minus 16? X plus 4, x minus 4. Is everybody good with this kind of factoring? If you know your times tables, this is super easy, right? But even if you don't, you can always do one of these lists that your teacher in grade 5 had you make, pairs of factors, right? Everybody cool? It's a lot like how we were breaking down radicals, right? If you know your division, you're in good shape. Everybody okay? All right. I'm going to shut up and leave you with half an hour to do... I am going to reverse this and make this page the practice So make sure you do it. I'll put the right answers up in about 15 minutes, 20 minutes, so you can mark your work. And I'm going to make this page the assignment for marks. What? I'd like it to be. I mean, look how fast you can do this, right? And you got half an hour. Okay, now, it's 9 o'clock now. At around 9:15, 9:20, I'll put up all these answers because really it literally takes 2 seconds. I don't write anything down. I can do these all in my head. Okay? So you guys practice. Yes. Of what? I loved it. You may check 1 to 6. The only tricks in this so far was in number 4. I haven't taught you officially how to deal with what's in pink, but if you were paying attention to the last 2 or 3 questions on the practice notes, you know what to do with what's in pink. But even if you don't worry, you're learning it tomorrow. And I tricked you a little bit on 6 by messing with the order.
There's no X on number 3 on 2X.
Oh yeah, there shouldn't be an X there. Thank you. Suhani. Okay. Everyone is good on 1 to 6? How many people sat around on number 6 going, oh, there's no factors of 9 that add to 20. But you've... Exactly. You don't like how it looks, so you switch it around. Kanika. Yeah. Well, just to make the pattern work for yourself. Now,
could number 7 be just X plus 8 and then X minus 8?
Of course, because order doesn't matter.
Oh.
Now, stop for a moment. Catherine just asked if this is okay. Yes, because these brackets group this as one factor, right? So that is factor 1 times factor 2. In multiplying, order doesn't matter. 5 times 2 is the same as 2 times 5. So that's why you can write these in either order. But you have to be careful on ones like this if they have different signs. The signs have to be in the right spot. Okay? Any questions here? McKenna. I'll get to that in a minute. What? Yeah, okay. All right, so everybody needs to see a number 11. Yeah, we'll get to it. So, everyone is okay with 8? Everyone is okay with 8? 9, 10. Now, 11, you're taking issues. Yes, you're right. So, we did notice that in every other one, the first term is always the square root of the quadratic term, yes? So we're all okay to get from x to the 4th to x squared, yes? Now, because there's a linear term here, I know that it's not going to drop out. So these two numbers aren't going to be the same. Just like letter M on the previous page. You know what to do when it's x squared and nothing, right? Then it would be x minus 2, x minus 5. So all you have to recognize is that when you expand this, you're going to get this. Yes? The negative 5 should be a positive 5. Thank you.
-5 and then -2.
No. And then in 12, you also, of course, could have written it like this. Because they're the same, so it's squared. All right? Both of those are acceptable.
Why couldn't he do +5 like -2?
Because that's what I have. I have +5 and -2.
But is it incorrect for it to be?
No, of course not, Catherine. That's what you... No. Because
I asked you, you said it was.
what I heard you say, and I apologize, I heard you say, could it be -5, +2?
Oh, okay.
Because we were in the process of just explaining that you can change the order of the whole factor, but not the inside bits. That's what I thought you said. I'm sorry.
I'll forgive you.
All right. Is everybody good? Okay. You've now seen how to do a bunch of them. The next page, I'm going to be marking tomorrow. All right? You got 9 minutes left now. There's only, I think, 12 questions on it. It's because the whole unit is based on this. McKenna. Oh, it's x squared minus 2. In this next page, you are going to need to be very careful with 8, 9, and 10. You're going to need to do a lot of thinking, but you have the knowledge. Apply what you know to 8, 9, and 10, and you will be just fine.